Hi guys, this is Mr. Urrego. Welcome back to our Geometry EOC review. We're solving the computer-based practice exam, and this exam is from the official Florida end of course exam website. So this is official, guys. We gotta study this thing. All right. This is session 2. Technically, it's with the calculators, and they'll give you, if needed, they'll give you an online calculator. You don't need a handheld calculator. All right. So this is session 2. We start with question number 20. Number 20. Let's read number 20. Okay. So click on each blank to select statement for row 3 and row 5. So this is a proof. I got to complete the 3 and 5. This is the given information on the left side. Okay. Triangle RST is a right triangle. RST. So the big triangle is a right triangle. SV, the symbol is perpendicular to RT. SV, perpendicular to RT. Yes, that makes sense. 90-degree angle. And now they're saying that triangle RST, which is the big triangle, is similar to SVT. SVT. So the big triangle is similar to this triangle on the right side. Alright, this little one. They're similar to each other. Alright, cool. The next statement is triangle RST is similar to RVS. RST is the big triangle, is similar to RVS. RVS. So they're saying that the big triangle is similar to this triangle on the left side. So I'm going to call that 2. So this is the little triangle, the medium, and then RST is the big triangle. Okay? I'm going to call that 1 on the right side, the little one, 2 on the left side, and 3 will be the big triangle. They want me to prove a squared plus b squared equals c squared, which is the Pythagorean theorem. I don't have to do the whole proof. I just need to complete 3 and 5. So let's check number 3. So I was checking number 3, and I have a bunch of proportions. These proportions, I wrote them down here. I wrote the first one. A is to B like B is to C. A is to B like B is to C. That's how you read those proportions. And then after that, I have a second proportion. If the first one makes sense, then we'll check the second one. All right? A is to C like C is to B. That's the second one. Third one, A is to D like C is to A. A is to D like C is to A. And the last one, A is to D like B is to E. That's the last one. So let's check this. All right. As soon as I hit that, it's going to go away. All right. Here my proof. This is the given information. The big one is similar to the little one. The big one is similar to the medium one. Therefore, the little one is similar to the... This is the little one is similar to the medium one, and it's called transitive because I'm comparing 3 triangles, the little one, the medium, and the big triangle. Okay. Then here, there's going to be the definition of similarity. All right. And the definition of similarity is where I have all these proportions. I need to check and see which one makes sense. Let's check. First one. A is to B like B is to C. A is this side, is to B. So I'm comparing the long leg and the short leg of the big triangle. Okay? All right. Let me make a drawing. Hold on. All right. So I have these 3 little triangles. This is a big triangle, A, B, and C. Big triangle. This is the triangle on the left side. Okay. And this is the triangle on the right side, the little one. And now I think it's a little bit more clear. Okay. So this is a right triangle as well. So let's compare it. A is to B, so the big one. A is to B, long leg over short leg. Equal. Now this has to belong either to the medium or little one. B is to C. B, I don't have a C. And here I don't have either B or C. So this proportion does not make sense because when I am comparing or between similar triangles, I got to compare, let's say, the big one with the medium, or the medium with the little one, or the little one with the big one. Okay? But I don't have a relationship right now. It does not make sense. Next one. A is to C. Okay, this could be from the big one. A is to C, so long leg over hypotenuse. C is to B. Again, none of this has C. So because of the C, that doesn't make sense. Again, I cannot repeat the same triangle. All right, they're saying A is to C, like C is to B. I cannot compare the same triangle in proportion. Does not make sense. Next one, A is to D, like C is to A. All right, A is to D, so I don't have a D on the big one, so I gotta choose one of this. So A is to D, so I'm doing hypotenuse over long leg. A is to D, like C is to A. Again, this is the hypotenuse, this is the long leg, and this is the short leg of this triangle. A is to D, like C is to A. Hypotenuse over long leg, C to A. Hypotenuse over long leg. You see this triangle? This side is shorter than this one. So this is your short leg and this is your long leg. The longest across the 90 is your hypotenuse. Keep that in mind. Alright, in this triangle, this is the hypotenuse, this is the long leg, and this is the short leg. Alright, so A is to D, hypotenuse over long leg, C over A, hypotenuse over, so this is the right one. So it's statement number 3. Let's check statement number 3. 3, B is to E like C is to B. B is to C, B-E, C-B. Let's check that one. B is to E. B is to E. Hypotenuse, short leg, like C is to B. Hypotenuse, short leg. Yes. So my statement right here is the third one. Makes sense. Excellent. Now here says addition property of equality. Addition property of equality. What are they adding? Are they doing this? Let's check. Let's check what we see. A squared, we have, okay. Alright, a squared plus b squared is not a Pythagorean theorem. Oh, hold on, look at this. Alright, so I have these proportions. So let's erase these proportions. Okay. So what about if I do cross multiplication here? Yeah, these people are crazy. Alright, let's take the first one for example. What about if I do cross multiplication? A times A squared. When I do cross multiplication, this diagonal is equal to the other diagonal, which is C times D. And what about the other side? So let's put a semicolon and let's do this one. B times B is going to give me B squared, which is equal to E times C, or C times E. I don't know the order. And now they're saying addition property. What about if I add these two things? We always do in a proof is statements, the previous statements. That's why I look over here to understand what was going on number 5. Okay, this comes from previous statements. My previous statements is number 4, number 3. Right now I have number 3. Okay, and I just did the cross multiplication. What about if I add these two things? Left side with left side, obviously, a squared plus b squared, and then the right side with the right side, CD plus EC. Let's check if we have something like that. Anything remote familiar. A squared plus b squared, I do have those two things here. And then I have DE, I don't have DE. Oh, I have CD. Plus, in our case is EC, but EC and CE is the same thing. So look at this. Alright, a squared plus b squared, that's what I have here, equals CD plus CE. This EC, instead of writing like that, I just flip the letters. CE. That's right. And we're done. Nice problem. Let's go to the next one, 21. So we have question 21. Points A, B, and C are collinear, and AB is to BC like 2 is to 5. Okay. Point A is located at -3, 6. Point B is located at NQ, and C is located at -3, 4. What are the values of N and Q? So NQ is basically point B. So they're asking me for point B. So the easiest thing is, because they give me points, I'm going to plot them. I'm going to locate them to see what's going on. Alright, so let's get a, see, I have a marker. Alright, cool. So -3, 6, that's point A. -3, 6, that's A. B, I have no idea. C, -3, -4. -3, -4. Okay, so if you notice, they have -3 as the x value. That means they are in some kind of vertical line. Alright, so let's do a vertical line here. So let's connect those points, right, real quick. Oops, I don't think it's working too well. Better. Alright, and this point is point C, and this is -3, 6, and this is -3, -4. Okay, alright, and the proportion between that from A to B is 2 to 5. Okay, so let's see how long is this. It's from here to here. So from the axis to the top I have 6, from the axis to the bottom I have 4, -4, so the whole thing is 10. Okay, my proportion, is 2 to 5. Okay, 2 to 5, so because I have 10 steps, right, so the whole idea, so we understand is AB to AC is 2 to 5. So what's happening is from A to B, let me write that better. So, and from A to C. Okay, so from A to B I have 2 steps, and from A to C I have 5 steps. But A to C is the whole thing. So technically what I need to do is I need to divide this into 5 sections. But the whole thing is 10. So every section is going to be, there's 1, so it's 2 pieces. That's 1 section. Another 2 is another section, another 2 is another section, another 2 is another section. So I have 2, 4, 6, 8, and 10, which is the whole thing. But I need to divide into 4 pieces because from A to C is 5. Out of those 5, I'm going to take 2 sections, and that's going to be from A to B. So out of those 5 sections, 1, 2, 3, 4, 5, I want to take 2, 1 and 2. And here is going to be point B. Alright? Remember, every section is made out of 2. Why? Because I have 10 divided by 5 is going to give me 2. Now they're asking me for the coordinates of A and Q, which is point B. Now what are the coordinates of this point? I'm going to go -1, 2, 3 in X, and then I'm going to go in Y, 1 and 2. So that's N, and this is Q. Okay? So let's type that in. N is -3, Q is 2, and we're done. Let's go to 22. Okay, so let's do 22. The first thing that I see in 22, they show me this figure. DE is parallel to BC. DE is the line at the top, parallel to the line at the bottom. Okay. Is a proof. They give me statements at the bottom and reasons. Let's see the question. Drag statements from the statements column and reasons from the reasons column to the correct location to complete the proof. Okay, I gotta complete those. I have 4 blanks. I have 4 answers. I have 1, 2, 3, 4 blanks. I got 2, 4 answers. Great. Let's look at the drawing and see, hopefully it makes sense. Okay, so the first thing that they're saying is that this line is parallel to the line on the bottom. Okay, why is that? When I have 2 lines that are parallel to each other, so this line is parallel to BC. So what happens? This line is a transversal somehow. So I can say that this angle is alternate interior angle with this, right? Because this is a transversal. But I can also say that this angle here is alternate interior angle with this, and this will be the transversal, right? So that's from the drawing. I believe this is going to help us. Now let's go to the bottom and see what's going on. All right, so now we know those angles. So this is angle EAC and congruent to angle ACB. All right, let's check. So let's go to the bottom and see. Let's erase that so it doesn't bother us. So B is parallel to that, okay. EAC is congruent to ABC, EAC, ACB. EAC, oh that's right, there we go. There we go with the angles. EAC with ACB. Yeah, those two angles are alternate interior angles. Okay, EAC, let's check EAC. So EAC. Alright, and those are alternate interior angles. Here we go, right away. Oh, what about the other ones? DAB. Let's look at DAB. DAB, this angle on the top. Alright, DAB, ABC. DAB with ABC. Yes, they're saying this angle with this. Those are alternate interior angles. So let's get that right away. Here, and those are alternate interior angles. Here we go. Nice. Next, DAE. DAE. The straight line equals 180. Of course, 180. But how do we know that? Because that's supplementary angles. The sum of those three angles equals 180, so that's supplementary. Do we have supplementary? Yes, we do have supplementary. Alright, that's why it's equal 180. Now we have angle addition. Angle addition. We're adding angles. Look, we're adding angles. That's it. DAB, CAB, EAC. Let's look at those angles. DAB, DAB. Next one is CAB, CAB, the one in the middle. So DAB is the one on the left. The other one right here. The other one is CAB, the middle. And the last one is EAC. EAC, which is the one on the right side. So when you add those three angles, you get the big one, which is DAE. And that's angle addition. You're adding angles. Angle addition. My last one is, I have no idea, but there's only one reason. There's only one statement, which is when you add the three angles equals to 180, you're replacing. And that's substitution. Okay, you're substituting the angles. DAB, that, the same thing, equals 180. Why? Because remember, from the previous statement, we said that DAE was 180. On the last one, we replaced the AE by 180, and that's called substitution. We're substituting that answer. Nice. All right. Next one, 23. Let's go. All right, question number 23. Quadrilateral math, very appropriate, MATH, is the little bit scale factor 2.5, okay? Scale factor 2.5. Center at 1.1, center here. To create quadrilateral M prime, 8 prime, T prime, and H prime. So this is the transform already, and it's going to be a dilation. So it's going to get bigger. Select the statements that are true about the dilation. All right. So first of all, let's do the dilation real quick. So 2.5. So if this side is 2 times 2.5 is going to give you what? 5. So 1, 2, 3, 4, 5. All right. This side, it's diagonal, oh my god, so it's going to be, okay, so I'm not able to do it perfectly, but something like that, 2.5, right? And the third line, it's parallel to HT, right? So I'm going to have a line like that, 2.5 times, something like that. And then this side, and the new MH prime is going to be parallel to this, so something like that. Alright, so that should be connected over here in the bottom. Okay, and when I have a dilation, remember that it was centered at A. Alright, so that everything started at A, and it got dilated in this direction, and this direction, and this direction. Alright, that was the idea. That's why it says center at 1, 1. Okay, so something like that. Alright, let's get started. MA is congruent to MA. No, this, by the way, this is A, this is M, and this is going to be M prime. This is going to be H prime. And this is T, so this is T prime. right? And A is the same as A prime because that's where it started, that's where it's centered. First question, MA is congruent to M prime A prime. No, obviously not. That's wrong. AT will overlap, AT prime will overlap AT. That's right, look at AT and AT prime overlapping, yes. Let's select right there. MA prime will overlap MA. MA prime will overlap MA, yes. There's one on top of the other one, that's right. The slope of HT is equal to the slope of HT prime, yes. HT and the slope of HT prime will be the same, that's right. Not only that one, but this side as well, MH and MH prime, all right? Because the slope of the four lines, and slope means they're parallel lines. This is the same direction as that. AT is the same direction as AT prime. You know, all of them have the same direction, same slope. The last one, the area of MA prime is equal to 2 times the area of MAT. Holy cow, no, not really. Not because it got dilated, because technically I got dilated 2.5s on every side. So my area is not going to go to that. Do we want to go here? Hold on, let me think about a short example. So I just created this example real quick. I'm going to have a blue triangle here on the right side. All right, I'm going to have a blue triangle, which is the little one. And I'm going to call that this side, the base is 2, and this is a right triangle. The base is 2, and the height is 1. And then I'm going to use a scale factor 2.5. It's the same thing. And I'm going to have a red triangle, which is going to be my B triangle. All right. So again, this is just to show you that it's not because the area, not because my dilation was 2.5, my area is going to happen the same thing to my area. So if I want to find the area, my little triangle is going to be base times height divided by 2. Base times height divided by 2, right? So my base is 2. My height is 1 divided by 2. 2 times 1 is 2 divided by 2 is 1. So the area of the little triangle is 1. Now the big one. My scale factor is 2.5. So this is 2 times 2.5 is going to give me 5. The blue triangle, this side is 1. My scale factor is 2.5. 1 times 2.5. The big triangle is 2.5. That's going to be my base, and this is going to be my height. Area, base, 5 times 2.5 divided by 2. All right? 5 times 2.5 is going to give you 12.5 divided by 2 is 6.25. So, as you can see, the area of the big triangle is not 2.5 times the area of the little triangle, is 6.25 times. Same thing happens here. I didn't do it here because the trapezoid is much, it's this diagonal, base 1 times base 2 is divided by 2. It's a longer formula, that's why I didn't do it. But again, you can prove easily using the formula. Let me get this thing, just in case you're up to it. Area of the trapezoid is 1/2 of the height times base 1 plus base 2. That's the formula for the area of the trapezoid. And then you have to find this diagonal. Okay? It's a little bit confusing. But again, I just prove you with a simple example of triangles that that's not true. Okay? So the last one is wrong. So this is my answers. All right, 23. All right, let's work in 24. Circle Q has a radius r in units. The measure of angle AQB is x degrees, as shown. By the way, when this is inside a circle and Q is the center, this is called central angle. So this x is central angle, and I want to use it in a minute. That's the central angle, okay? Create an expression using r and x that can be used to find the length of arc AB in units. B is then create an expression that could be used to find the length of AB in units. Okay. In circle Q, we're dilated by a scale factor of 3.7, and here's the calculator. Okay, excellent. All right, so I guess I don't need this anymore. I know x is my central angle, and that's about the information that I need from down there. All right, so here we go. Okay, so x is my central angle. Now, if you notice I put on the top this formula. My arc length is equal to theta, which is my central angle, divided by 360 times my circumference. 2 pi radius is my circumference. So this is how I find the arc AB. Alright, so let me erase this real quick. Okay, and let's get our, red. So I'm going to find the arc length of AB. Alright, AB is equal to theta. Theta is the central angle, which is x degrees, divided by 360. Okay, time 360 degrees, by the way, times 2 pi radius. 2 pi, and the radius is radius, right? Is r, and x with the degrees. Can I reduce this? Yes, I can. This 2, I can divide it by 2 on the top, which is going to be 1, and divide by 2 on the bottom, which is 180. So I reduce the 2 on the 360. So here I'm going to have x divided by 180 times pi radius. So that'll be the expression for A. Alright? And then B, create an expression that could be used to find the length of arc AB in units if circle Q were dilated by a scale factor. So for part B, the only thing is that I need to multiply by my scale factor 3.7. This times 3.7. So technically I just put 3.7 in the beginning. So let's type this in. So my first answer is going to be, I need a fraction, so fraction. I put x on the top, 180 on the bottom, on the side, times, I'm going to put a parenthesis, safe with parenthesis, and it says it's going to be pi times radius, right? Pi times radius. Okay, pi times radius was pi. Pi. Here's pi. Times radius. So where's times? Multiplication. I believe that's multiplication times radius. And this is the r. Okay, close parenthesis. Oops. How can I erase that? Close parenthesis, close parenthesis. Oh, my computer. There we go. And I put a parenthesis, close parenthesis with my computer. And that's the expression. X over 180 times pi radius. Next, they're saying, how can I put that dilated by 3.7? So the only thing that I have to do is multiply times 3.7. So I'm going to put 3.7, okay, times x. Technically, I don't have to put times, right? That's 3.7x. And I'm going to type everything else. 180, parenthesis, pi on the right side, times radius, and I close with my keyboard. Alright, so by putting 3.7 times x, that's where the dilation is occurring. And that will be 24. Again, practice using this calculator. Alright, let's go to 25. Okay, so we have 25 now. Let's read the whole thing and see what the question is. I have a calculator on the bottom, AB, okay. The trunk of a palm tree has cylindrical tubes that carry water. So I guess this is a palm tree trunk, this is the tube. Each tube is 0.0003 meters wide. If this is the width, then that means that the diameter. Okay, interesting. So this is the diameter. One of the tubes in a palm tree trunk is shown. Okay, this is one tube. Alright, let's read. Using the diagram as a model, approximate how many tubes could fit in a palm tree trunk with the diameter of 0.5 meters. Okay, the tubes in a palm tree are between 20 to 21 meters long. What is the approximate volume in cubic meters of one tube? Alright, so one step at a time. So what they're saying right now is they're giving me each tube is 0.003 meters wide. Meters wide means wide, that's your, if it's a tube, it's circular, right? So that's a circle. So that the width is your diameter. So this is your diameter. Okay. They're saying if the trunk is 0.5 meters in diameter as well, how many tubes can you fit? So what I need to do is find the area of each one of them. Okay. You see this? I'm going to color the top of each tube right now. So this is the top of that tube. I'm going to have how many of those can I fit in the whole area. So what I need to do is I need to find the area of the tube. Okay, I know the area of a circle is pi r squared. Alright, but the tube, they gave me that the diameter was, let me double check again. What was the number? Diameter was 3 zeros and a 3. 3 zeros and a 3, okay? 3 zeros and a 3. So my diameter is 1, 2, 3 meters. Therefore, the radius is half of this. So half of this is going to give me 1, 2, 3. Let's say that this is a 30, so half of 30 is 15. 3 zeros, 15. That's the radius. So let's find the area of the tube. So the area of the tube is going to be pi, this, 1, 2, 3, 15 to the second power. Okay? Now, then they asked me for the how many of these on my trunk. So let's do the trunk with blue. Okay, I'll do the math in a minute. So the area of a trunk is the same thing. It's a circle. So it's pi r squared. But they didn't give you the radius, they give you the diameter, which is 0.5 meters. Half of 0.5 is 0.25. So pi, that's the radius to the second power. Okay, so if you notice here for the tube I have pi, here for the trunk I have pi, so I'm not going to use pi, I'm just going to find the decimal. Okay, so let's find this in the calculator. It's going to give me let me see what number is that. So that's 0.123 15 to the second power, and that's going to give me a lot of zeros. Let's see, 1 2 3 4 5 6 7. So 1 2 3 4 5 6 7 225, and I didn't touch the pi, so it doesn't give me more decimals. And that's the area of a tube. Okay, now let's do the same thing over here. 0.25 squared. That's going to give me 0.0625 times pi. Alright, so this is each tube, this is the trunk. Which one is bigger? The trunk. So I need to know how many of these goes in here. So what I need to do is, in order for me to do is I divide this divided by this, and that's going to give me the number of tubes. Alright, the big number divided by the small number. So the number of tubes is going to be given by 0.0625 pi over this number. Oh my god, 1 2 3 4 5 6 7 225 times pi. You notice that I didn't use pi? Guess what? Can I cancel pi from the top and pi from the bottom? Yes, I can reduce that. Alright, so let's do this. So let's divide that divided by this. So divided by 1 2 3 4 5 6 7 225, and that's going to give me 2,777,778. There we go. Somebody rang on my door, so I'm sorry about that. Alright, so this is the amount of tubes that I have in that trunk. Now let's work on part B. The tubes in the palm tree are between 20 to 21 meters long. What is the approximate value in cubic meters of one tube? Okay, so they give me a range. Alright, so guys, if you notice, this is a cylinder. Okay, so the area of the cylinder, let me see if I have a pen. Alright, the volume of a cylinder, the volume of a cylinder is the area of the circle times the height. This is the height. And the area of the circle is all this. Alright, which we have. They're asking me for the tube. Okay, I have the area of the tube up here. Okay, now they're giving me two things. The tubes in the palm tree are between 20 to 21. What is the approximate volume in cubic meters of one tube? So let's get the area. So volume of the cylinder is the area of the circle times my height. The area of the circle in this case is on my tube. So I'm going to bring that. How many zeros I have? 7. 1, 2, 3. I think 7. 1, 2, 3, 4, 5, 6, 7 zeros. 225 times pi, and that's the area times my height. The first height they gave me was 20, so times 20, and this number is going to be, let me put this in the calculator, equals, how many zeros is that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 141. So when the height is 20, this is the volume. When the height is 21, let's find out. So area of the circle is the same thing. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 225. Now instead of the height being, pi, I'm missing pi. Instead of the height being 20, it's going to be 21. I multiply all that and I have 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 148. Again, remember, what are my units? What are my units? This is meters. So because this is volume, this is meters to the third power. This is meters to the third power. Because this is area, then this is meters to the second power. I'm sorry, not times. This is meters to the second power, right? And this is meters to the second power because this is area. So what is the approximate value in cubic meters of one tube? So you can give any value between this and that. Anywhere from 5 zeros 141 to 5 zeros 148 could be a possible answer because that's the range that they're giving me. Now let's put that answer here and we are called it a day. Hold on, let's get it here. Let's type it. So my first answer is the amount of tubes, which is 2,000,000. 1, 2, 3, 1, 2, 8. All right, and the second answer is anywhere from here to here. So I can say 0 point, and there was 5 zeros. 1, 2, 3, 4, 5, and I can say, just to make sure that I don't make a mistake, 142. In between 141 and 148, and we're done. Because the tube in the palm tree, what is the approximate value in cubic meters of one tube? So anywhere between that range, because they're not giving you, a place where to put a range of two values. And that will be my answer. All right, guys, we finished 25. 38 minutes. We're going to continue in the next one. Again, subscribe to the channel, like the video. Make sure you hit the notifications bell so you can get notified when the next video is coming on. And again, I'll have more videos for the EOC, alright? So the idea is to make a good review packet for everybody so you guys get strong and, when you get to the EOC, go for a 5. That's the whole idea. Alright? Thank you for watching. Again, subscribe. You have the subscription on the subscribe button right there in front of your face. So, in front of your face, not too good. Subscribe, guys. Take care. I'll see you next one.